Good morning, students. So far we have been discussing about Cauchy-Riemann equation, Cauchy integral formula, Cauchy integral theorem, then complex integrals in complex numbers. And these techniques and theorems are used for solving some tedious problems in integration. And related to Cauchy-Riemann equation, and today we are going to see many problems. The first problem goes like this. Show that if f of z equals u plus ib is an analytic function, f is given as vi plus uj is a vector, then div f equal to 0 and curl f equal to 0. So condition has been given as del dot f equals 0 and del cross f equal to 0 are equivalent to Cauchy-Riemann equation. So condition has been given like this, and we know the Cauchy-Riemann condition goes like this: partial du by dx equals dv by dy, and dv by dx equals minus partial du by dy. So f has been given as f equals vi plus uj. So first we will go with del dot f, div f. So del dot f is given as, for del, this is your expression. Del equals, del is a vector quantity. So del equals partial id by dx plus j partial d by dy plus k partial d by dz. Dot is here. So dot, and your f is given as f. So you are going to have a dot product of these two. Okay. So del dot f, the expression for del is given as this one, and this is your v. You are going to have a dot product. I dot I, j dot j, k dot k, something like that. So you have I dot I will give you dv by dx. Your j dot j will give you du by dy, and there is no k term here. So we have obtained dv by dx plus du by dy. What is given? Div f equal to 0. The condition is div f equal to 0. You substitute x, which is equal to 0. So div f equal to 0, that implies that dv by dx equals minus du by dy. This is one of the Cauchy-Riemann equation. Okay. So now we will go for the second one. Second one is curl f. Curl f stands for del cross f. So del cross f is a vector quantity. The resultant will be a vector quantity. So you have ijk partial d by dx, d by dy, d by dz, and v vector exists, u vector exists, whereas there is no k vector. Correct? Your I vector vi plus uj, which is nothing but your f. So k equal to 0. There is no k component. So k equal to 0. So which is the condition is which is equal to 0. So now we will go for k term alone. This term will become 0. Everything will become 0. Now we will go for only kth term. So kth term will give you this multiplied by this minus this multiplied by this. So that is partial du by dx minus partial dv by dy equal to 0. Correct? The condition is f equals 0. Okay, curl f equal to 0. So this is equal to 0. So you just take this term to that side. This term to that side. So you have du by dx minus dv by dy. You just take that term. So that will give you du by dx equals dv by dy, which is one of the Cauchy-Riemann equations. Okay. Thus the f of z equals u plus I is an analytic function, provided this del f equal to 0 and curl f equal to 0 are equivalent to Cauchy-Riemann equations. Very simple one. Now we will go for problem 2. Construct, this very important problem. Construct the analytic function f of z. The real part is given. Now we are going to do the process in a reverse way. So we are going to construct now analytic function. Earlier the function will be given, f of z equals u plus iv. So we know already. Now we are going to construct a reverse way. We are going to construct f of z equals u plus iv, whereas u is given. So we will have to find out v using CR equation. Is it clear? See, u is given. To construct analytic function, f of z equals u plus iv. U is given. We will have to find out v using Cauchy-Riemann equation. We can do it easily. And we can add these two, that will give you f of z, u plus iv. So u is given as e to the power x cos y. So we are going to differentiate with respect to x. So du by dx. Du by dx will give you e power x. We are going to differentiate again e power x. So e power x cos y. Is it okay? Now du by dy. E power x cos y we are going to minus sin y. So minus e power x sin y. The differential equation of u is given as. So this is the original differential equation which we have seen already in the first video's lecture itself. dv equals, this is the definition for your actual differentiation. dv equals dv by dx partial dv by dx plus partial dv by dy. This is the actual differentiation. Okay, so now what is here? Using Cauchy-Riemann's equation, dv by dx equal to minus dv by dy, dv by dx equals dv by dy. Instead of dv by dx, I can write this as minus du by dy. So minus du by dy. Is it okay? Instead of dv by dx, use CR equation and replace your dv by dx by minus du by dy. What is dv by dy? Du by dx. See, du by dx. Now we have already found everything in terms of u. Du by dx, du by dy. We can substitute. Okay, so dv becomes. So du by dy is minus. Already one minus is there. So minus plus. So minus e power x sin y dx plus du by dx is nothing but e power x cos y dy. So just integrate on both sides. So that will give you v. You are going to integrate this one with respect to x. So sin y becomes constant. I have pulled out. So e power x, when you are going to integrate, answer is e power x. So e power x sin y. Similarly, cos y, we are going to integrate cos y, that becomes sin y. So this is the answer. So we have obtained now v. Already we know u. So u plus iv will be f of z. What is asked? Construct the analytic function. So v equals e power x sin y plus e. Your f of z will be u plus iv. U is given, v is given. Of course, when you are going to have a constant integration, there must be a integration constant. So plus c. Okay. Now e power x is common. I have pulled out. So e power x cos y plus I sin y. E power x. This can be written as e power iy. Can you remember? Yesterday in the last video lecture we discussed about. So e power iy is given as this. Now e power x, e power iy is nothing but e power x plus iy. X plus iy is nothing but z. So your f of z equal to e power s. This is your analytic function. So we have constructed the analytic function and u is given. We have obtained v through Cauchy-Riemann equation and we have obtained the analytic function. Many doubt? These type of problems are very important. Okay. So u is given. We will have to find out v. Then u plus iv will give you f of z. Similarly on the other way around also. V will be given. We will have to find out u. It can be also given. And you will have to add u plus iv, that will give you f of z. It can be given on the other way around. Any doubt on this problem? Now we will go for problem 3. See, as I said, v is given. Okay, earlier in the problem u was given. So now it is v is given. So real part is, this is imaginary part is given. You will have to find out the real part. Determine the analytic function f of z, which is equal to mu plus iv when v equals 6xy minus 5x plus 3. Express the result of the function of z. Express the result as a function of z means f of z. You will have to find out f of z. So now v is given. So v equals 6xy minus 5x plus 3. So as usual you will have to find out where x and y are there. Okay, as usual you will have to find out dv by dx, dv by dy. So dv by dx equals, come on, you will have to find out now. V is given as 6xy minus 5x plus 3. So dv by dx, you will have to differentiate with respect to x. So this becomes 6y. This becomes minus 5. This becomes 0. So 6y minus 5. Now dv by dy. So in this, you will have to differentiate with respect to y. So dv by dy is given as 6x. This becomes 0. This becomes 0. So we have found out dv by dy. Okay, so b is given. So as usual, you have to go only with u. So the actual differentiation of u is given as du partial du by dx. So this must be your partial du by dx. So that's a mistake here. Partial du by dx plus partial du by dy. So these two should be replaced by Cauchy-Riemann's equation as usual, the same procedure. So we know that Cauchy-Riemann's equation given by this, and we know the earlier equation, and du by dx can be replaced by dv by dy. So dv by dx. Similarly, your du by dy can be replaced by minus dv by dx. So we have replaced now. Now du is dv by dy already we have found out. So it is nothing but 6x dx. So minus dv by dx is nothing but 6y minus 5. This dy is there. Now just integrate on both sides will give you v. Sorry, u. So u equals, you are going to integrate now. So 6x squared by 2. Correct? 6 you pull out. Integration of x dx will be x squared by 2. So x squared by 2. Similarly, you can go for y squared by 2. 5y. Don't forget this is minus 5y plus as usual plus c, integration constant. So now you can strike it out. So this will become 3x squared. You can strike it out, that will give you minus 3y squared plus 5y minus into minus plus. So plus 5y plus c. So your f of z will be u plus iv. So u we have found out this u, v it is given in the problem. So u plus iv. So this is your f of z, analytic function. So we have constructed f of z, v was given and we will have to find out u. So u plus iv will give you f of z. Any doubt? Simple. Now we will go for problem 4. Determine the analytic function whose real part is given. So what is the real part? U or v? U is a real part. So u is given x cube minus 3x y squared plus 3x squared minus 3y squared plus 1. So u is given now. So u is given as this. Just differentiate with respect to x. So du by dx is nothing but 3x squared. So this must be minus 3y squared. You have to differentiate with respect to x. So minus 3y squared. This becomes 6x. This becomes 0. This becomes 0. So we have found out now du by dx. Now du by dy. Du by dy, this will be 0. Very good. Then this one will be 3 2s are 6. So 6 minus 6xy. Correct? You are going to differentiate. This will become 2y. X is a constant. With respect to y, you are going to differentiate. So this becomes 2y. 2y multiplied by 3 will give you 6. So 6xy. Minus, this becomes 0. This becomes minus xy. So that will become 0. So we have found out du by dx, du by dy. Now as usual, we will have to go with the total differentiation. So dv equals partial dv by dx plus partial dv by dy. As usual, we will have to replace this by Cauchy-Riemann's equations. The same procedure. We are going to replace. So we have replaced with the Cauchy-Riemann equation in terms of u. Okay, so dv equals, now du by dy already we have found out, du by dy, which is nothing but minus. So that also minus is that. So minus will get cancelled. So that will become plus. See here, everything will become. Okay, this is minus is there. Already we have a minus sign. So minus minus plus, so this will become plus. Now du by dx is given by this. Now integrating on both sides. Just integrate on both sides. That will give you, this will be your v, and integrating on right hand side will be this one. So integrating with respect to x you will do. So 6y will become a constant and your x squared by 2. So x squared by 2. This one will be 6x. 6y is constant. So you have dx. When you are going to integrate dx, that will give you x. So 6x. Already y is there. So 6xy. Plus you are going to integrate with respect to y. So this becomes 3x squared y. This becomes minus 3y cube by 3. This becomes 6xy and integration constant. Now very important thing is repeated terms should be vanished. We should not take the repeated terms here usually. So here the repeated terms are 3x square 3x squared y. See here it is 3x squared, correct? 3x squared y. Here you have 3x squared y. Is it okay? Here 6xy. Here also 6xy. The repeated terms should not be taken into account. So we are not going to have the repeated terms. So this becomes, you have 3x squared y, 6xy. Here 3 will cancel. So minus y cube plus c. So this is your v. Okay. So in this problem, the repeated terms should not be taken into account. Okay. We will have to take only one term. So 3x squared y, we have 3x squared y, the repeated terms. So we have written only once. So 3x squared y plus 6xy minus y cube plus c. So v is obtained. Already we know u is given. So u plus iv will give you f of z. So f of z will be u plus iv. So this is wrong. This is f of z. F of z equals u plus iv. Any doubt? Now it's very important one in complex number. This is about Cauchy's residue theorem, and we learned already about Cauchy's integral theorem, integral formula we learned. So when you are going for any contour problem, for any integration of any complex number, then the integration c f of z dz equal to 0. So yesterday in the last video lecture we learnt about Cauchy's integral formula, integral theorem. Can you remember? So in that theorem it says that for any contour problem, for any closed problem, the integration with respect to c f of z dz equal to 0. Okay, f of z dz equal to 0. So this is what we learned. Suppose there exists some residues. There exists some residues. Residues means some remaining things, some left out. Suppose we are going to transmit one signal from one part to another part. For any signal problem, the complex number is used in electronics. I repeat, in an electronic subject, for any signal problem, the complex number is used. Suppose I am going to transmit from one system to another system, from one part to another part, the signal. Some signal while transmission, some signals will be left out. Some signals will be left out. Those left out signals are called residues. Okay, so those remaining things. Earlier I said the integration f of z dz equal to 0, correct? That is for Cauchy's integral theorem that we know already. F of z dz equal to 0. However, in certain points some remains will be there, some left out will be there, some residues will be there. In those places we call this as poles, singular points. Those places it will not be equal to 0. It will not be analytical. For everything, everywhere it will be analytical, except those points in which there is a singularity, what we call this as pole, some remains will be there. Those points it will not be analytical. Is it okay? It will not be analytical. So we have to add all the points in which some points will not have analytical solution. Those solutions are called Cauchy residue theorem. Okay, very simple one. We will see elaborately now. For example, we take the picture. So for example, when you take the picture, suppose if this is for the contour problem. So in the last video lecture we learnt about integration of f of z dz equal to 0. So when you are going to integrate for a complex number, we are going to have this contour problem, integration of f of z dz equal to 0. Now I have certain points here inside. Those points are called poles, singular points, and at these points the function will not be analytical. Here the function will be analytical. Some points will not be analytical. Some remains will be there, some left out will be there. What we call this residues. So we have to add all the residues here. So this is the idea. F of z is analytical at all points inside under simple closed curve C, except at a finite number of poles, the dot points, poles, what we call singular points. For example, z1, z2, dot, zn within C. then the Cauchy residue theorem says that f of z dz equals 2 pi I times sum of residues. Those residues, we'll have to go to add those residues. So 2 pi I times sum of residues of f of z at z1, z2, dot 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 zn. So f of z dz is given as 2 pi I residues of z1, residues of z2, dot 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 residues of zn. Now we are going to prove this one. Around each of the singular points z1, z2, dot 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 zn, draw small non-intersecting circles c1, c2, c3, cn, all lie within C. So you have to draw that small circle, and here also we have a small circle which we call this a C3. This will be your C2, small circle C1. This will be your C4. So Cauchy integral formula extended to such regions leads to that we know already, that I have already told you that integration f of z dz equal to 0. So in the last video lecture we learned. Now for all small circles C1, C2, C3, that also will be equal to 0. But those points inside the points will not be. Okay. So here the integrals are taken in the anticlockwise direction. As I told you in the last video lecture, we are going to have only counterclockwise direction. So now you just keep these things, other things just bring that to that side, so you will get this. But at similar points, where the poles, some remains will be there, some things will be left out, some signals will be left out. Those things are called residues, which are nothing but 2 pi I times residues of your f of z at the point z1 plus 2 pi I times residues of f of z at the point z2. So similarly dot dot dot. So I can add all those things. So I can sum it. So 2 pi I times sum of residues of all the points of f of z. So your f of z dz is given as 2 pi I times sum of residues of poles which are inside C. Okay, so that's the idea. So this is the formula for Cauchy residue theorem. Your f of z dz is given as 2 pi I times sum of residues of poles which lie inside